Section 5.5 on multiple and angles and product to sum formulas. So there's going to be a bunch of different formulas on this section, but most of the time they're going to tell you what formula, or it'll be easy to figure out which one you're going to use. So the double angle formulas are if you're trying to find an angle that is bigger than what's on your plate, or 2 times what is on your plate. And if you notice, you have a formula for sine and tangent, and then for cosine you have 3 different formulas. You can use any one, providing whatever information you're given, that will help you determine which one you want to use. The half angle formulas are if you want to find an angle that is half the size of something on your plate. And you notice on the sine and cosine there's a positive and a negative there. That is determined by which quadrant your angle would land in on the unit circle. So for example, if you have 15 degrees, 15 degrees is in quadrant 1, so everything is in quadrant 1, so you're going to choose the positive for the sine and cosine. But if your angle landed in quadrant 3, only tangent is positive in quadrant 3, so you would use the negative sine and cosine. Okay, so the next formulas are the product to sum formulas and the sum to product formulas, and they do exactly what they say. If you're going from the product of 2 things and you want it to be the sum, then you use those. If you're going from the sum of 2 things and you want it to be a product, then you use the second set of formulas. Most of the time they're going to tell you which one to use, or what type of formula to use, not which one specifically, but which type of formula to use. And the last ones are the power reducing formulas, and they take from a squared term or something to a power to, as you can see in the formulas, a double angle. Okay, and you can use them vice versa. If you have a double angle and you want something squared, you can go the other way. So in example 1, we have a triangle with all 3 sides labeled, and we're supposed to find the exact value of tangent to theta. So the formula for tangent to theta is 2 tangent theta divided by 1 minus tangent squared theta. So in order to use this formula, I need to find the tangent of theta using this triangle. So looking at the triangle, tangent is opposite over adjacent. So the tangent of this angle is going to be 1/4. So I'm going to plug 1/4 into both of the places that says tangent theta in the formula. So that's going to be 2 times 1/4 divided by 1 minus 1/4 squared. So now it's just a matter of simplifying. 2 times 1/4 is going to be 1/2. On the bottom, 1 minus 1/4 squared is 1/16. Okay, so we've got fractions within fractions, so we want to multiply everything times the greatest common denominator, which in this case is going to be 16. So we multiply every piece in the equation times 16. So 1/2 of 16 is 8, over 16 times 1 is 16, and then 1/16 times 16 will just be 1, so 16 minus 1 on the bottom. Well, we know that 16 minus 1 is 15, so this is going to be 8 over 15. So this is the tangent of 2 theta. Okay, number 2 wants us to find the exact value. So this is kind of like what we did in section 3, where we're solving the equation. We're going to find the angles that fit the solution. So I don't know what to do with the cosine 2x, so I can use the double angle formulas to replace that with something that might help me out better in the equation. So I'm going to replace cosine 2x with 2 cosine squared x minus 1. And then the rest of the equation stays the same. Minus cosine x equals 0. Well, if I rearrange this equation, it's going to look like 2 cosine squared x minus cosine x minus 1 equals 0. And if you notice, this is a trinomial. We've seen this before in Algebra 2. It's just like this equation, 2x squared minus x minus 1. And in Algebra 2, we learned how to factor these into 2 sets of parentheses. So the two things that multiply to get 2x squared are 2x and x. And the two things that multiply to get 1 on the end are 1 and 1. We just need to figure out what our signs need to be in the middle. So in order to get a negative x in the middle, that's the outside and inside term. And for the outside term, that would be a 2x, inside would be 1x. So in order for me to add 2x and 1x to equal a negative x, then I'm going to have to put a negative where the 2 times 1 would be, and then a positive where the 1 times x would be. Okay, so our problem over here works just like this. We're going to set up our two sets of parentheses. So the two things that multiply to get 2 cosine squared x are going to be 2 cosine x times cosine x. The two things that multiply to get 1 are 1 and 1. And then same as the last problem, to get the negative cosine x in the middle, the negative needs to go with 2 cosine x times 1. And then a positive 1 times cosine x to get the middle term. Now I'm going to set these two pieces equal to 0 so that I can solve. So if I solve 2 cosine x plus 1 and get cosine by itself, cosine x is going to equal negative 1/2. And if I solve cosine x minus 1, cosine x is going to equal 1. So then I'm going to look on my unit circle to find where cosine is negative 1/2 and also where cosine is 1. And those angles turn out to be 2 pi over 3, 4 pi over 3, 0, and 2 pi. Okay, so example 3 says to rewrite as a double angle. So I've got 6 cosine squared x minus 3 equals 0. So I'm going to take the cosine squared x and I want to find something that I can replace it with. So if you look at your power reducing formulas, the cosine squared x can be replaced with something that has a double angle in it. So I'm going to leave the 6 and I'm going to replace cosine squared x with what it equals on the power reducing formulas, which is 1 plus cosine 2x over 2. And then everything else stays the same. Minus 3 equals 0. So I could distribute the 6 in the parenthesis, but I would wind up having to divide everything by 2. So go ahead and take the 2 and divide it into 6, and it goes 3 times evenly. So then I lose the fraction. Then I can distribute the 3. 3 times 1 is 3. 3 times cosine 2x will be 3 cosine 2x. And then we still have the minus 3 equals 0. And you notice the 3 at the front and the negative 3 at the back, those are going to cancel. So I'm just left with 3 cosine 2x equals 0. Now they didn't ask me to solve this problem. If they asked me to solve or find the exact values, we could go from here. But this one just wanted us to rewrite it as a double angle. Okay, number 4 wants us to find the sine 2u, cosine 2u, and tangent 2u for this angle, given that the sine of u is negative 4 over 5. And then it says that angle u is between pi and 3 pi over 2. So if it's between pi and 3 pi over 2, that means that angle u is in quadrant 3. So I'm going to draw myself a coordinate plane and a triangle in quadrant 3 and label with the information that they gave me. Sine of u is negative 4 over 5. So that means opposite is negative 4, hypotenuse is 5. So that's going to make the adjacent side negative 3. So now I can find that the cosine of u is negative 3 over 5. The tangent will be negative 4 over 3, negative 3, which will be a positive 4 over 3. So now that I have these three things, I can find the sine 2u, cosine 2u, and tangent 2u. So sine 2u, the formula is 2 times sine u cosine u. So we're just going to plug in these three pieces. So 2 times -4/5 times -3/5. So we multiply the 2 across the top. So 2 times -4 times -3 is going to be 24 over, on the bottom, 5 times 5, which will be 25. So the sine of 2u will be 24 over 25. Cosine 2u, you can use any of the three formulas that are provided. I'm going to go ahead and use cosine squared u minus sine squared u. So this is going to be -3 over 5 squared minus -4 over 5 squared. So -3 over 5 squared will be 9 over 25 minus -4 over 5 will be 16 over 25. So then 9 over 25 minus 16 over 25 is going to be -7 over 25. Okay, and then last will be the tangent. So you could use the tangent formula, or I'm going to go ahead and do sine divided by cosine. We just found out that the sine was 24 over 25 divided by the cosine, -7 over 25. So when I flip the second fraction and change it to multiplication, 24 over 25 times -25 over 7, the 25s are going to cancel. So then 24 times the negative that's still there over 7 will give me -24 over 7. So those are sine 2u, cosine 2u, and tangent 2u. Okay, number 5, we're given a triangle and we're asked to find the cosecant of theta over 2. Well, I don't have a formula for a half angle of cosecant, so I'm going to use the sine half angle formula. When I get my answer in the end, I'll just flip it to get the cosecant. So the half angle formula for sine is the positive or negative square root of 1 minus cosine u over 2. Now this time I didn't put the negative, I'm only using the positive because this triangle looks like it would be drawn in quadrant 1 and everything's positive in quadrant 1. Okay, so we just need the cosine of this angle to plug into this formula. So cosine of this angle is going to be 15 over 7. So it's going to be the square root of 1 minus 15 over 7 all over 2. So we want to get rid of the fractions within fractions, so our smallest denominator is going to be 17. So we're going to multiply everything in the equation times 17. So that's going to be 17 minus 15 over 34. So on top, 17 minus 15 will be 2 over 34. Then we're going to take the square root of the top and bottom. Actually, 2 over 34 will reduce first to 1 over 17. Then we'll take the square root of the top and bottom. Square root of 1 is 1, and square root of 17 will stay. Now, if we were looking for the sine, then I would go ahead and fix the radical. But since we're wanting the cosecant, I'm going to flip this anyway, so the cosecant turns out to be just the square root of 17. Okay, example 6 tests to use the half angle formulas to determine the exact value of the sine, cosine, and tangent. So the angle that we're trying to find is pi over 8. So we want to think about what angle on our unit circle divided by 2 would equal pi over 8. And that turns out to be pi over 4. Okay, so we're going to find the sine, cosine, and tangent using pi over 4. That's what we will plug into each of the formulas. But in the end, it's going to result in the sine, cosine, and tangent of pi over 8. So this is the half angle formula, sine pi over 4 over 2. And since pi over 8 would be in quadrant 1, then everything's going to be positive here in our answers. So this will be the square root of 1 minus the cosine of pi over 4 all over 2. So cosine of pi over 4 we know is square root of 2 over 2. So this is going to be 1 minus the square root of 2 over 2 divided by 2. We want to get rid of the extra fraction, so we're going to multiply everything times 2. So that's going to give us the square root of 2 minus the square root of 2 all over 4. Then we want to split up the square root in the top and bottom. So the top is just the square root of 2 minus square root 2 over the square root of 4. So I know you've probably never seen that before, but it's okay to have a radical underneath a radical. They don't cancel out because the 2 underneath are being subtracted together. So we can't do anything with the extra radical. We're just going to leave it as square root of 2 minus square root 2. And then on the bottom, the square root of 4 is 2. So this is the sine of pi over 8. Okay, so now we're going to do the cosine and the tangent. So cosine of pi over 4 over 2, the formula looks a lot like the last one. It's the square root of 1 plus cosine pi over 4 over 2. So this works out pretty similar because it's going to be the square root of 1 plus square root of 2 over 2 divided by 2. So again, we're going to multiply everything by 2. So that's going to give us 2 plus square root 2 over 4. I'm going to separate the radical top and bottom. So square root of 2 plus square root 2 over the square root of 4, which is 2. Now this is just a coincidence that these are so similar because the cosine of pi over 4 and the sine of pi over 4 are the same number. That's why this worked out that way. It's not always going to be nice and neat. Okay, so now we're going to do the tangent of pi over 4 over 2. So it's going to be 1 minus the cosine of pi over 4 over the sine of pi over 4. So 1 minus square root of 2 over 2 divided by square root of 2 over 2. So first we're going to multiply everything by 2 to get rid of the extra fractions. So that's going to be 2 minus square root of 2 on top over square root of 2. I can't have a square root of 2 on the bottom, so I'm going to multiply top and bottom times the square root of 2. So when I multiply square root of 2 times 2, that's going to be 2 square root of 2. And when I do negative square root of 2 times square root of 2, that's just going to be minus 2 all over 2. We have to distribute to both pieces on the top. Okay, I can factor a 2 out of the top, so that will be 2 times square root of 2 minus 1 all over 2. So the 2 that we factored out will cancel with the 2 on the bottom, and that's just going to leave us with the square root of 2 minus 1. So those three were the sine, cosine, and tangent of pi over 8, and we had to use pi over 4 to plug into our formulas. Okay, number 7 wants us to use the product to sum formulas to write as a sum or difference. So we've got cosine 4 theta times sine 6 theta. So 4 theta is our u and 6 theta is our v. And we're going to look for the formula that has cosine u sine v. So that formula looks like 1/2 of sine of 4 theta plus 6 theta minus sine of 4 theta minus 6 theta. So we're just going to simplify as much as we can inside the parentheses. So this is going to be 1/2 of sine 4 theta plus 6 theta is 10 theta. And then minus sine 4 theta minus 6 theta is negative 2 theta. Okay, and there's nothing else we can do here, so we're just going to box this in. We can't add a sine of 10 theta and a sine of negative 2 theta. Those don't add together. They're not the same angle. So that's all we can do to this problem. Okay, 8 says use the sum to product formulas to find the exact value. So here we have a difference, but that's the same as saying a sum, and we're going to change it from a sum to a product. So cosine 3 pi over 4 minus cosine pi over 4, we need to identify our u and our v. So we're looking for the cosine U minus cosine V formula. So that says negative 2 times the sine of 3 pi over 4 plus pi over 4 over 2 times the sine of 3 pi over 4 minus pi over 4 over 2. Okay, so we're going to simplify in the parentheses first. So negative 2 times the sine of, when I add 3 pi over 4 plus 1 pi over 4, that's going to equal 1 whole pi, or 4 pi over 4 is 1 pi. And then divided by 2 will just be pi over 2. Second parenthesis, 3 pi over 4 minus 1 pi over 4 will give me 1/2 of a pi. And then when I take half of a pi and then divide it by 2, that's going to give me sine of pi over 4. So now I can find these values. Negative 2, the sine of pi over 2 is 1. The sine of pi over 4 is square root of 2 over 2. So now I'm just going to multiply these two together. So negative 2 times 1 times square root of 2 over 2. The 2 on the bottom and this 2 out front are going to cancel, so this will just wind up being negative square root of 2. Okay, so your homework is on page 415, 2 through 14 every other even, 22 through 62 every other even, and 64 through 88 every other even, or evens on the end.